Greetings everyone. Today we're going to start exploring factoring. You'll want your foldable notes provided to you in class. Hang on to these because we're going to keep adding to them and they'll be vital in your understanding of this entire unit. Let's go over a quick refresher on how to multiply binomials. A couple of different methods you might have learned in the past. The first one could have been FOIL. FOIL stands for first, outer, inner, last. Your first terms, x times x is x squared. Your outer terms are -1 times x. Your inner terms are 3 times x. And your last terms are 3 times -1. Then we simplify by combining like terms. And then we have our trinomial. Another method you may have learned is called the box method. Each term gets a side, and each piece of the term gets its own row or column. We multiply x times x, we multiply 3 times x, we multiply -1 times x, we multiply -1 times 3. Then we combine the like terms from within the boxes. -1x plus 3x gives me 2x and -3. We're not only considering multiplying binomials, but these are also called factors. This process of multiplying you have used before. So for factoring, we're going to do the reverse of this process. We're going to start with the polynomial, and we want to get the factors. Let's take a look at one more example. If I used FOIL on this one, first would give me x times x, outer would give me -3x, inner would give me 3x, and last would give me -9. If I combine like terms, -3x plus 3x cancels out, and I'm left with x squared minus 9. Notice the pattern here. The inner and outer terms canceled. When you have the same value but of opposite signs in your binomials, the outer and inner will always cancel. Notice these trends as we go through our factoring process. This can allow factoring to go a lot quicker if you notice the patterns. You have your foldable provided to you in class. Hang on to this. This is going to be vital throughout this entire unit and into next semester. You're going to use it all the time. Let's open up that top flap that says Factoring Quadratics. Factor, what does it mean? You have 2 bullets. Let's take care of the first bullet. What does factor mean? It means to find out what was originally multiplied to create the expression or polynomial. If you need to pause this video to jot these notes down, please do so. The second bullet should be undo the multiplication process. So just like the previous examples, we multiplied 2 binomials and we got a trinomial. We're going to undo it. We're going to have the trinomial and break it up into 2 binomials. Let's add this little example below our bullets. For example, x squared plus 3x minus 4. This is an expression that is not factored. Let's also add in there x plus 4 times x minus 1. This is written as a product of factors. The left one is not factored, the right one is factored. You do not have to jot this down, but you've taken binomials and multiplied them to get a product. So what's going to be new is taking that expression and finding its factors. Open up to that second flap. Under Greatest Common Factoring, GCF. You've dealt with GCF in the past. GCF is what is the largest number and/or variables that can be divided out of every term in that expression. Take a moment to pause to jot that down. Let's look at the examples below that note. Example 1. Our goal is to find our GCF, the greatest common factor. What number and/or letter can I divide out? So I'm just carrying those notes over since I don't have them in front of me, but you do. Let's take a look at our numbers here first. I have 6, -12, and 18. What number divides into all of those evenly? In this case, a 6. Let's take a look at the letters. I've got an x squared, an x, and no x. If I don't have an x, I can't divide one out. So all I can divide out is a 6. Divide out a 6, a 6, a 6. Let's see what we have remaining. 6 divided by 6 is 1. So I have an x squared. Bring down my sign. 12 divided by 6 is 2. Leave the x. Bring down the sign. 18 divided by 6 is 3. Close your parenthesis. We just took out or divided out our GCF. Let's take a look at example 2. What number can I divide out of 14 and 7? In this case, 7. That's my greatest common factor for numbers. Let's take a look at our variables. I have an x to the 4th and an x. So what's the most x's I can divide out? Just one of them. Let's see what we have remaining. If I divide 14 by 7, I have 2. I'm dividing out a 7x here. That was what I was going to divide out. 14 divided by 7 is 2. X to the 4th divided by x. Now that x has an exponent of 1. We take the 4 minus the 1. When we divide variables, we subtract their exponents. So I have x to the 3rd remaining. Bring down my sign. 7 divided by 7 is 1. X divided by itself is also 1. So I have to have a value there. Anything divided by itself is 1. My GCF that I factored out was 7x. Let's look at one more. This one's a little more challenging. Take a look at the numbers first. I have 28, 16, and 8. Let's take a look. 8 goes into 8, 8 goes into 16, but 8 does not go into 28 evenly. Let's try 4. 4 goes into 8, 4 goes into 16, and 4 goes into 28. So I can evenly divide a 4 out of everything. Let's take a look at our x's. I have x squared, x to the 5th, x to the 1st. Therefore, I can only take out one x out of all of those. Let's take a look at our y's. I have y to the 1st, y to the 1st, y to the 2nd, which means the most I can divide out of all of those is y to the 1st. Therefore, that repetition becomes your GCF. Let's write what we have remaining when we divide that out. 28 divided by 4 gives me 7. X squared divided by x, we subtract the exponents, which leaves me with x to the 1st. Y divided by y is 1. So I don't need to write a 1 there. Let's bring our sign down. 16 divided by 4 is 4. X to the 5th divided by x. I subtract the exponents and I end up with x to the 4th. Y divided by y is 1. I don't need to carry that down. Bring down your plus sign. 8 divided by 4 is 2. X divided by x is 1. I don't need to write that out. And y to the 2nd divided by y to the 1st leaves me with y to the 1st. Take a double look at what's remaining and make sure you can't divide anything else out. If you can divide something else out, that means you didn't get the biggest GCF to begin with. Always take the largest value you can divide out evenly. Let's flip open to the next page in our foldable. Factor by grouping. When there are 4 terms, what do we do? The first step is to group into pairs and factor out a GCF of each group. If you want to label these as step 1 and step 2, that might be helpful as well. So we group the first 2 into a pair, the second 2 terms into a pair, and then we do GCF. Then we do one more step of factoring, and we factor out what is in common one more time. Let's take a look at the examples for factoring by grouping. Look up at your bullets and your first steps. Your first step says to group pairs. Take the first 2 and put them in parentheses, and take the second 2 and put them into parentheses. Keep that sign with the 5, by the way. Take a look at that first set of parentheses and find a GCF. What can I divide out of 2 and 12? A 2. What can I divide out of an x cubed and an x squared? At most, I can take out or divide out an x squared. That becomes my GCF of the first parentheses. That GCF is 2x squared. Let's write what we have remaining. 2 divided by 2 is 1. X cubed divided by x squared leaves me with x to the first. Bring down my sign. 12 divided by 2 is 6. X squared divided by x squared is 1, so I don't need to write that. Let's take a look at our second set of parentheses and what we can divide out. What can I divide out of negative 5 and negative 30? A negative 5 can come out of both of those. Make sure if they're both negative that you divide out a negative. That is part of your greatest common factor. If I take a look at variables, this one has an x, this one doesn't. So I cannot divide out any variables. This becomes my GCF. Let's see what we have remaining. Negative 5 divided by negative 5 is 1. Bring down the x. Bring down my sign. Negative 30 divided by negative 5 is positive 6. Close that parenthesis. Notice the pattern. When you do GCF correctly when grouping, you should always end up with the same thing twice. If you don't, there's your first hint to not continue and to fix your mistakes. That was, again, step 1. Step 2 says factor one more time. What do both of these terms have in common? They have in common an x plus 6. If I divide out or factor out an x plus 6, I have a 2x squared and a minus 5 remaining. Take a look at how that worked. If I divide out the x squared plus 6, then I write what's remaining after I've divided it out. Let's take a look at a couple more examples. Example 2, group the first 2, group the second 2. Let's determine my GCF. 2 and 4. What can I divide out of both of those? A 2. I have an x cubed and an x squared. At most, my largest factor I can divide out is an x squared. There's my GCF. I have a 2x squared. When I divide that out, 2 divided by 2 is 1. X cubed divided by x squared is 1 remaining. Bring down your sign. 4 divided by 2 is 2. X squared divided by x squared is 1, so I don't need to bring that down. Take a look at the second set of parentheses. I've got a 1x and a 2. The only value I can divide out is a 1 on this one. Even if it's a 1, write it out. Divide that 1 out. As for variables, I only have an x. I don't have an x here. So 1 is the only thing I can divide out. So that becomes my GCF. It's a positive 1. If I divide out a positive 1, 1 divided by 1 is 1. Bring down the x. Bring down the sign. 2 divided by 1 is 2. Take a look. This should always happen. You should have the same thing twice. So for step 2, I want to divide out that common factor. When I divide out my common factor of x plus 2, then what I have remaining, 2x squared plus 1, becomes my second factor. Let's take a look at one more example. Group the first two and the last two. In the first two, I've got a 12 and a 9. My greatest common factor would be a 3. Let's take a look at our variables. I've got an x squared and an x. So the most I can divide out of both of those is an x. And then I have no y and a y. Therefore, I cannot divide a y out. So my first GCF is 3x. Let's see what's remaining. 12 divided by 3 is 4. X squared divided by x is x. Bring down the sign. 9 divided by 3 is 3. X divided by x is 1. So I do not have to write a 1. And y divided by no y just stays. We'll bring it down. Close that off. Take a look at our second set of parentheses. I've got a -4 and a -3. The only common factor there would be a -1. Let's take a look at our variables. I have an x here, but no x here. So I can't divide any x's out. I've got a y and a y squared. I can divide out a y out of both of those. This becomes my second GCF, -1y. -4 divided by -1 is 4. X divided by no x's, so it just stays. Y divided by y is 1. So I do not need to write that down. -3 divided by -1 is +3. Y squared divided by y is y to the first. Here's a big hint again. Notice I got the same thing twice. You guys, this should happen every time. If it doesn't, check your greatest common factors. Step 2, let's factor out that common factor. If I factor out 4x plus 3y, what I have remaining is 3x and a -1y. Notice on each of these answers, they're all binomials. If you want to FOIL them out or use the box method, you should end up back at the question. So technically on every question, you can check your answer on these. Just for a quick recap, we had two major points that we discussed in this video. The first one was GCF, finding your greatest common factor, dividing that out, and then writing what's remaining. The second main point was factoring by grouping. When you're factoring by grouping, you're using GCF just in a larger capacity. With factoring by grouping, when you take out your GCFs, you should always have the same factor remaining. That's a hint that you're doing it correctly. You have a worksheet with some practice problems that are specific to these two main points. If you get stuck, refer back to this video for help. Watching the video once sometimes isn't enough. Going back and watching some little clips of it again can be very helpful. We'll chat next time, and if you have any questions, let me know.